Alright, so welcome to this assignment. We're going to get solutions going for the vertical and horizontal stretch or shrink. Our first set here are just some conceptual questions about what shrinking and stretching does. If you have a function, describe what will happen to a function when replaced with 3 times the function. And you can think of the function itself being all the y values. And so if you got 3 times all the y values, you're going to have a vertical stretch. Is just going to stretch all the y values by a factor of 3. So you could think of it as like being 3 times all the y values. G, describe what happened when replaced with 1/4 inside the parenthesis there. If you're got something inside the parenthesis, it kind of does the opposite. Mostly, as what it does on the outside. So if you got 1/4 of x, of all the x values, you're going to have actually a horizontal stretch. Because even though it's 1/4 of the x's, you need to divide all the x values by 1/4 to do the transformations. And if you divide, so like you got some number like 3, and you divide by 1/4, that becomes 3 times 4, which is 12. And so it's stretching the x values out. So it's a horizontal stretch. Next one, what would happen if a function replaced with 2 times the function that's already got a change inside the 2x? Remember, the inside, it kind of does the opposite. You take all the x values and divide by 2. And so this would have a horizontal shrink. But on the outside, we're timing everything by 2, so all the y values get stretched. And so we're going to have a vertical stretch. Moving on to 4. Here, the 5 inside is going to give us a horizontal shrink. Because you have to divide all the x's by 5. And on the outside, we got 1/3 times h. And so you're taking all your y values and you're timesing it by 1/3, which is going to give you a vertical shrink. So both of them, we got both a vertical and a horizontal shrink on 4. Moving on to the next one. On 5 through 7, you're using this function, which comes from these table values. And we're going to do a different transformation. Now I've already put the original on there in black, and so I'm going to put the transformed version in red. In order to do this to f of x, you're going to do 2 times all the function values, so 2 times all the y values. The x values are going to stay the same, the y values will become doubled. So this guy here and this guy here both have a y value of 2, so you have to times it by 2 to get then their new y value. This has a y value of 4, so you have to times it by 2 to get the new y value, which is going to be 8. And it's similar on this side. 1, 2, 3, 4, 5, 6, 8. Yep, just making sure I'm getting all the right y values here. This guy here used to have a y value of 1. You need to times it by 2 to get a new y value. And both of these guys have a y value of -1. So you have to times them both by 2, which is -2. So those are the new points for those. And so our new function looks like this red one. Okay, the red one is what the transformed one would look like. Okay, notice same function, x values are the same, it's just been stretched vertically. Moving on to 6, we have to do 1/2 of the function, and so you're going to take all the y values here and cut them in half. This used to have a y value of 2, it's now 1. Same thing over here. This used to have a y value of 4. Now it's 2. Same on the other side. This used to have a y value of 1. Now its new one is going to be 1/2. These both used to have a y value of -1. Now it's going to be -1/2 for both of those. And so the red guy here is our new function. And you notice it's the same x values, just the y values have been stretched out. And moving on to 7, we need to do a vertical stretch, the 2 times all the y values, and then move them all down 2. And so this has got 2 different transformations going on at once. Do the stretching first, then subtract 2. And so we already did the vertical stretch over on number 5. So we're going to basically redraw that. But all the points are going to go down 2. So this guy would go up to 4, but then down 2. And so he actually stays there. But this guy, when you times his y value by 2, you'll get 8. Take it down 2 to get 6. And you get the same on the other side. I like how this is symmetrical figure. It makes it easier to figure this out. This guy, you need to stretch it times 2 to make it negative 2, but then take it down 2. So he's all the way down here. Other side, same thing. This guy times by 2 to get up to 2 for your y value, but then you need to take it down 2 because of the vertical transformation. And so we have our new function here. And it should look like number 5, but just down 2, because that's the only difference here. Okay, that's going to be it for that whole assignment. Ta-da!